In this video, I'm going to talk about concave lens ray diagrams and the lens equation. And so here I have a concave lens, so it's concave on both sides. And I'm going to say the focal point is here, is at 5 centimeters. Although it's actually called a virtual focal point, which you'll see in a minute what I mean. And then I want to put an object over here at about 10 centimeters. And we're going to locate its image. So when light enters a concave lens, it actually diverges. And this light ray, it goes parallel to the principal axis. When it gets here, it actually refracts and bends outward. And it bends outward in such a way that if I extend this line back, it goes through this focal point, which is a virtual focal point, because the actual light ray does not go through it. The actual light ray goes this way due to refraction. But if I trace it backward, it's a virtual focal point. I can also draw a line like I did before with convex mirror lenses, a line that goes through the center of the lens. I'll draw that one in there right around here. And I use the same logic. These two light rays will not touch each other, they won't intersect. But if I trace them backwards, which one of them I already did, and I trace this one backwards, which is basically on the ray itself, they actually meet right about here. So I see a smaller image. And because it's not the light rays themselves, but the extensions of them backwards that meet, you get a virtual image. So that you follow basically the same rules as convex lens rays, except this ray on the top bends outwards because of the refraction of light, but we can trace it back to a virtual focal point. So for the quantitative part for solving for DI, to see what that actually is, we're going to use the lens equation again. 1 over F equals 1 over D O plus 1 over DI. I'm going to list my variables again, F, DO, and DI. Now, because this is a virtual focal point, my focal length is not 5, it's negative 5 centimeters. Very important point, the negative sign. The DO is still 10, and I'm trying to find DI. So I'm going to follow my 5-step process again. A, B, C, D, and E. So I'm going to say 1 over F is equal to 1 over D0 plus 1 over DI. This is 1 over 5 equals 1 over 10. This is negative 5 actually, plus 1 over DI. Don't forget the negative sign. And then, so I get negative 0.2 equals 0.1 plus 1 over DI. And then if I do the math for this, negative 0.3 equals 1 over DI. DI equals 1 over negative 0.3. That equals negative 3.33 centimeters. And I can box that final answer. So this object is located, again measuring from the center of the lens, 3.3 centimeters away from the center, and it's negative, meaning virtual. So we basically follow the same rules, and the key difference for concave lens is that we have virtual focal points, because this light ray bends outwards and never goes through a focal point, only its extension backwards does.